off, we will talk a bit about PCBs and then how to design them. And we will also talk about EagleCAD, and Rohit will give us a hands-on session on that. I hope that every one of you have installed it already, but even if some of you might have some doubts, so Rohit will be taking a 10-minute session for that. Okay. So first of all, what is PCB? Um, can anyone tell me the full form of PCB? Anyone? अरे इतना सन्नाटा क्यों है? कोई है? Anyone? Can anyone tell the full form?
See
Hello?
chat box. Someone raised hand.
Yeah, Rasmi has raised hand.
हेलो. लिटरली मुझे कुछ नहीं दिख रहा, तो मैं चाचा के जैसे ही हूँ, तो बताओ जल्दी. पीसीबी का फुल फॉर्म चाहिए गाइस. किसी को आता है?
Printed circuit board.
Yeah, exactly. Printed circuit board. Uh, so all around us, there are electronic devices. Whether it be they might be silently monitoring our health, for example, a Fitbit, or they may be annoying us with constant notifications, for example, our smartphones. And all of these have printed circuit boards at their core, which make them work. Okay. Now, before printed circuit boards, we had point-to-point wiring, which, as you can see, there was a wooden board on which many, literally hundreds of wires were there, and components were there, and everything was connected like that, as you can see in the pic. Now, all of us have had tangled earphones in our past, right? And you know how annoying that is. So make it 100 times worse. That is what these were, because they used to malfunction many times because the connections were very loose. So that's why they had many errors, and every time when you had to sort them out, it would take hours and hours, and still your mental state would become like Abhijit's. So that was it, and you were not able to move them. So wherever you made them, you had to use them there itself. Just like us nowadays, they were not able to go anywhere else. Okay. So there were some developments in PCB area starting from 20th century. There was some in early 2010, 1910s, but there was a gap here. Can anyone guess why? What was happening कि यहाँ पे development नहीं हुआ? Hello, raise your hands and can anyone guess कि 1930 से 25 के बीच में कोई development क्यों नहीं हुआ? Hello.
Aryan, they have answered in the chat box.
Okay, बता दो भाई. Okay, क्या आंसर क्या किया उन्होंने? दीपक.
They have answered correct. WW1.
Yeah, exactly. So World War One was happening, इसलिए कोई घर पे नहीं था, साइंस कोई नहीं पढ़ रहा था. So इसलिए there were no developments. But after the war ended, the development got some pace as the end of 1930s began. There was quite a lot of development, and this was because World War II दरवाजे पे था, and इस बार साइंस का काफी भारी उपयोग किया गया था. तो in World War II, we saw many new scientific example. For example, radar. There was sonar, and there was also cryptography. Do you know कि जो पहला computer था ENIAC, that was also just built to break Nazi codes, to get the Nazi secrets of where the bombings were going to happen in the hands of US and UK. So if all these heavy machinery, they needed electronic components, and for that we had to make circuits a bit more useful. So इस कारण से उस टाइम पे सर्किट बोर्ड्स के अंदर हेवी डेवलपमेंट हुआ था एंड दे इन्वेस्टेड हेवीली इन दोज टाइम्स. So that's why you can see कि यहाँ पे consecutively काफ़ी development हुआ था. After the end of war, finally the PCB technology came to public and it became a thing of households. But in the early 1960s, especially in radio sets and such, but फिर भी अभी भी TV या ऐसी चीज़ों के अंदर PCB use नहीं कर पाते थे. For example, this is a handmade PCB, but still इसके अंदर wires नहीं है, so it is a much better model than what used to be earlier, wire to wire contact वाला. Okay. After then came the era of ICs, and ICs, they were a game changer. They replaced vacuum tubes. These vacuum tubes, they were very bulky and very costly, but the ICs that replaced them, they were cheap to manufacture and they were very small. So you were able to easily put them on a circuit board, and that is why इससे उनका काफ़ी growth हुआ. So with these advent of ICs, gradually motherboards का भी चलन जो है बढ़ा. So motherboards got prominence, due to which general computers, they came into effect, and that is and with computers came softwares. For example, computer aided design software CADs, these came into effect, and इससे again PCB in CAD you are able to make PCBs more efficiently. So this is, for example, a feedback loop where development in PCB was able to make developments in computer science, which again gave to development to PCBs. And now we come to today, where 3D printing technology has developed enough that now we are using much more newer and better materials to print PCBs on even flexible things. For example, these curved LEDs that you see today, these are a product of printed 3D printed PCBs. So there are many benefits to PCB, ranging from their compact size and low cost to manufacture, to being having very low noise, electronic noise. For example, in wire-to-wire contact thing, there were a lot of wires, right? And these wires had lot of current, which again had which again had EMF effect due to their magnetic fields, and उससे काफी noise बढ़ जाता था. But with the PCBs, the connections are such कि noise जो है आज के time पे काफी reduce हो गया है, and you can easily repair these PCBs, and they are really reliable. So these are many benefits to PCB, and now I will hand over to Deepak, and he'll tell us more about the manufacturing of PCBs.
Yeah, hello.
Yeah, Deepak, you're audible.
Yeah. As of now, you are aware of PCB and its uses. Now I am going to tell about its composition and all other things. First of all, you see some boards, some circuits like your motherboard of your mobile, your laptop, your PC, and other equipments, electrical equipment. You want to know what is its composition and what are they made up of. What are different things that are joined together, that are fabricated, all other things. So first I go for composition. Here you can see, you can relate everything, every component with some material. Then here you can comparable as PCB as layer cake. It has alternating layers, and we can make it together and all the components jointed as a single object. Next, we are going for PCB layers. There are different layers. Some of them are substrate, copper, solder mask, and silk screen. Substrate is the base material, and we see there are at currently available market, there are many different objects are used to make this substrate. Here the substrates are commonly made using fiberglass, and you can find many thickness PCBs are present in the market. Next, the second most layer is copper layer, and you are aware that copper is the good conductor of current and heat, and here copper is used as a plate which conducts electricity, because the board is useful when it conducts electricity in a good manner, good way. And here is a question, quick question for you. Yeah, the question is, on a double-sided PCBs, copper is applied to. Option A is one side, option B is both sides. Give me your answer in the chat box. Yeah, both side answer is correct, because as seen in the figure, it has both side copper track, and in the middle it has substrate, and the answer is same here, both side. Now the third layer is solder mask, and solder mask is applied on copper, as accordingly substrate is the base, then copper, and then after that copper we use solder mask to cover them. And solder mask gives different colors to these PCB boards. That's it. You have any question that is coloring is required for PCB layers? No, not at all. Because the main function of this solder mask, as by the name, it has used as a mask. Like it cover the things of copper traces, so that if you touch them, you cannot feel a electric shock. To avoid that electric shock, we use solder mask. So it is necessary to have a solder mask over the copper board, so that you cannot get heated by the electric shock. Next, we will discuss about silk screen. And silk screen is applied over the solder mask. The green color is also due to solder mask, and above that solder mask, we will use this silk screen. And by the name, we define it as to mention naming of the joints and points. There is different holes, there is different socket, and these all. If we name it as a matter that here we name it as 0.1 microfarad. This means you can attach a capacitor here that have a large range of 0.1 microfarad. That's the use of silk screen. It gives the name to the board, name of every component to the board. Next, the things of evolution of CNC, because previous times there is not any CNC machines, so we can name it as evolution from the traditional to the next generation. And in the CNC machine, if you are asked to make a PCB of different components, what will you do? You will start trying these same as these workers. No, this photo is also a joke, because because you are thinking of this, then of course no. Then what is the process to add the components to these boards? The process is to add these boards, and to add components to these boards is the CNC machine, because CNC machines has an ability to make PCB boards in a quite minimum time with a large scale. Like you have to make 1,000 of 2,000 machine, 2,000 PCBs at a time, then this CNC machine will do the same. So this CNC machine will reduce your time and reduce your cost also. But these CNC machines are quite expensive, approx 20 to 30 lakhs for each machine. Some local machines are also available, but the range is quite comparable. The next thing is the fabrication, because PCB is made is not only the key element for this mating process. For this process, here the next The next technology of this era is the fabrication technology. This will reduce your sizes, because if you go for a market to buy a smartphone and a PC or any other things, then you think that I have to buy a slim smartphone or slim PC. There comes the importance of this fabrication process. It will make your component of a small size, and by the use of rails, it will diminish your overall device size. Next we are discussing about inner layer printing, because as of now you are aware that the PCB has 4 layers, mainly substrate and copper and 2 others. Then for inner layer printing, we have to print all the layers, the substrate and the copper and the all others. So for this printing, we go for some process like cleaning, insulation, etching, induction, these all, and in a clean room. Here is your question that why a clean room is required, why a yellow room is required. Then we will discuss about the things that there are many dust particles are generating at that time. And this video will elaborate about the things that why a yellow room is required and how dust particles are removed.
Print inner layers. To produce the inner layers of our
audible?
PCB, we start with a panel of laminates.
Yes.
We print the panels in a clean room to make sure that no dust gets onto the surface where it could cause a short or open circuit on the finished PCB. The clean panel is coated with a layer of photosensitive film, the photoresist. The bed of the printer has registration pins matching the holes on the photo tools and in the panel. The operator loads the first film onto the pins, then the coated panel, then the second film. The pins ensure that the top and bottom layers are precisely aligned. The printer uses powerful UV lamps which harden the photoresist through the clear film to define the copper pattern. Under the black areas, the resist remains unhardened. The clean room uses yellow lighting as the photoresist is sensitive to UV light. Outside the yellow room, the panel is sprayed with a powerful alkali solution, which removes the unhardened resist. The panel is pressure washed and dried. The copper pattern we want is now covered by the hardened resist. The operator checks a sample of the panels to make sure that the copper surface is clean and all the unwanted resist has been removed. You can now see in the blue resist what will be the copper on our inner layer panel.
Hello, Deepak, you are not audible. Hello. Deepak. Hello.
Yeah, hello.
Now you are audible. Go on.
Yeah, next we will discuss about layer alignment and AOI. We will elaborately discuss about AOI, what is its process and all the things. Yeah, layer alignment, you see that it has 4 layers, and you also imagine that all 4 layers are aligned in a sequential manner so that every equipment is utilized at the same manner. Then what is AOI? First watch this video, then we will describe about these things. Yeah, you see here that how the camera takes the picture of the PCB, and there are many errors. If there is an error, then these errors are captured and then go to the supercomputers. And this is called AOI because in this automatic optical inspection, the computer will design that where the errors are. Because if you are given a board and there are 1,000 and 2,000 errors, then if you sit back and found every errors and join and then correct it, then it will take a lot of time, like 1 or 2 days. But by this method, by AOI machinery, and if you take as a helping as a supercomputer, then it will detect and correct all the failures. Yeah. Now I am Yeah. Now I am hand over to Lahari to discuss about some limitations to PCB and how installation of EagleCAD and what different softwares you can use for the process of the PCB and to design the circuit boards.
Hello everyone, I am Lahari. Here I will discuss some limitations of PCB and little about EagleCAD. Okay, by now you have seen what is PCB and here how we design PCB. Also keep that PCBs are not made in heaven. They also have limitations. First limitation is low current uses. It is the first major drawback. PCBs are used in only devices with small current. If we manage to overcome this limitation, we can have a world with all small devices. Even you can have an electricity generator in your hand. Like anyone tell why we cannot use high current for PCBs? Use the chat box. I can able to see this. Like why are we not able to use the PCBs for high current? Yeah, exactly. Copper mites may catch fire and this will cause damage to the PCB. Yes, yes. So we are only able to use the PCBs for small currents. Okay, moving to the next limitation. It is a limitation while preparing PCB. Okay, what basically soldering is? I think you have learned in mechanical work lab in first year. Give a simple definition in your own words. What soldering basically means. Anyone? Yeah. Yes, yes. Connecting, yes, it's basically simply connecting two components with some heat. Here in PCB soldering, we use the through-hole technique. In this technique, we connect components of PCB into hole by melting it with hot soldering iron. Anyone know what the soldering iron is made up of? Okay, there are two components in the soldering iron. Anyone know what are the two components? Yes, great. Tin and lead. Yes. Soldering iron is made up of tin and lead. Moving to the next limitation of PCB, this is also a major drawback of PCB. Here, I think you are familiar with the breadboard, right? You have designed a voltage amplifier and you have to modify it into RC filter. As we know that all the components in voltage amplifier are required to make RC filter. So how do you will modify in a breadboard? Not PCB, I am talking about breadboard. Like all the components are same, just you have to only make the new connections. What you will do? Explain in simple words, like what you will do. You have all the components, but the connections are wrong. Like, will you take rearrange all the components and make a new circuit? Like you already have the components and you have to only change the connections. Yes, that is the process on breadboard. You can simply rearrange the components and make the new connections. But here this is a drawback of PCB. Once you have made a circuit, then you never be able to change the connections. You'll never be able to use for another circuit. So the PCBs are lack here. Moving to the next limitation, etching process. Okay, anyone definition of etching? Like, okay, I will tell it. Like, it is basically and simply it is removing an unwanted copper from the surface of PCB with some chemicals and leaving the pattern portion of the copper that are called traces. This, as this process involves chemicals that will be a danger to the environment and for us. So this is the limitation. Like ferric chloride and sulfuric acid hydrogen peroxide are not safe to use. And moving to the virtual platform. Okay, why we are nowadays using this virtual platform to design? Anyone guess it? It's very simple and you can make it any jokes also. Why we are using? Give some thoughts.
You can see from the photo too.
Yes, yes. Yeah. Okay, don't tell like that you are attending classes in online, so you are designing this PCB in online. Yes, yes, to avoid electrical failure. Yes, to avoid you to keep in this situation like risks. You will have to use the virtual platform before designing the PCB. Yes, here is one of the platform, EagleCAD is used for PCB. It will help you to catch errors beforehand. Okay, Eagle stands for Easily Applicable Graphical Layout Editor. And CAD, it is, anyone tell the full form of CAD? Think you are well known with it.
Computer aided design.
Yes, yes, exactly. Yes, computer aided design. Yes, it will let you draw the circuit schematic and it will allow us to run and simulate. Yes, here is an example for Arduino circuit designed on EagleCAD. You can also print and schematic. You can also made more complex circuit boards on EagleCAD like Raspberry Pi and etc. Yes, and further details of EagleCAD and how to design on the PCB will be discussed with Rohit. I am handing over this to Rohit.
Yes, thanks a lot, Lahari. Okay. So great. That was a very elucidating presentation, series of presentations, and I hope that all of you guys have gained a lot of theoretical knowledge from this, and it will help you when you really make PCB boards for yourself. Having said that, I'll show you a couple of things which we have laying in the electronics club. This is a soldering iron, which Lahari talked about. You plug in this port into a power socket and the tip heats up and you melt this metal called solder and join components on them. We also do have a PCB, an actual PCB. It looks like a green color board and it has copper paths on it. And on the flip side, there are multiple components. There are relays, buck pins, and etc. Also a push button. And this is the kind of thing which we will design subsequently. Having said that, I will start the demonstration part of the workshop. I will open the EagleCAD software on my system, and I invite you guys to open EagleCAD on your laptops and follow along with me. So I'll share my screen now. I hope my screen is visible. Let me know on the chat box. I can read your chats. Is my screen
It's
visible?
visible. It's visible.
Okay, brilliant, brilliant. Okay, so we have the PCA presentation. I'll open it. Okay, this is the wrong presentation. Just ignore this part. We'll directly open EagleCAD. Okay, before I start actually making circuits on these, let me know if all of you have been able to install EagleCAD. Do we have people who were not able to install or on whose laptops EagleCAD isn't launching? Okay, we do have Harsh who says he has problems. We have more. We have Rashmi, we have Anindya. Anindya is able. Okay, cool. Okay, we have a couple of people. There's a common error which occurs in many systems. Basically, we also have forwarded a specific link on the Discord channel. If you go there in the Discord announcements, we don't have the troubleshooting link there. Okay. I will ask my friends to send the troubleshooting link in the Teams chat. You guys can check it out there. Basically, you have to go and append a small .dll on a certain file in the computer files where your Eagle is installed. Okay, Deepak has sent the troubleshooting link on the Discord. Teams chat. If we have, okay, yeah, correct. You have to rename the libay file. I don't know how to pronounce that. But you do open this link, it will take you to a page, and there are three tricks which you can use. This is the rename libay file. This is what usually occurs. We solved many issues with that. Having said that, I'll wait for a couple minutes for you guys to apply that fix. And once you're ready, we'll go ahead and design our very own PCB. If you have any doubts at any time of the meet, you can write them on the chat box and we will try to solve them to the best of our abilities. Do let me know once you're ready to start. Okay, shall I move forward? Does anyone have any doubts till this point? Everybody has Eagle opened in the systems. Okay, very well. Okay. Having said that, let's begin our first circuit of the day. You have to go to the file section, new, and we'll create a new project especially for this workshop. Again, this is a hands-on session, so I would like to invite you guys to open Eagle on your systems and follow along the steps which I tell you. So you go to file and you create a new project. Okay, so we have a new project here. We can you can see the new project in the blue colored highlight in the left hand side of the screen. It's called a directory. We will call it PCB workshop. Now we are in that empty project. Once we are there, we'll create a new schematic. Okay, so I'll tell in brief what a PCB schematic is. It is the circuit diagram in the simplest of words. You have units which will describe the components which will appear on your circuit, and you connect wires with them. This is very similar to how you drew circuits with hand in your 11th, 12th days. Having said that, now I'll talk a little about the circuit we'll build in the first time today. We are planning to build an Arduino Nano based PIR sensor enabled intruder detector alarm. So that was a very big word. I'll break it down. We will use an Arduino Nano as the brains of the circuit. We will upload code on it and it will execute it. Then we have a PIR sensor. PIR stands for passive infrared. What that means, it's not actively putting out infrared, but it has an LED, infrared LED, which is like a lamp which washes the room with infrared glow. And it has a sensor which detects changes in the electronic infrared field. In fact, I will actually show you how a PIR sensor looks. We'll go to Google. So if you go to images, this is the kind of sensor we are talking about. There's a dome inside which there's the LED lamp, and there are receivers which detect changes in the light. Having said that, first we will import an Arduino Nano. So for that, this is the first tool of the day. It's called Add Part. You can see my mouse on the left side of the screen. So I click on Add Part. Again, I am urging you guys to do this thing along with me, because in the second part of the workshop, we'll select a lucky person who will perform PCB design on the Meet. Having said that, we'll insert asterisks. What these asterisks do, they kind of allow wildcard searches. So if I don't put these asterisks, the search will be very strict with case. You have to exactly write uppercase and lowercase letters. But now I can just write nano and search this thing. Okay. Oh, great. Before the thing is key, if you are following along with me, you might not be able to see this nano board with you. Why is that? Because of this. This is a SparkFun boards library, which is not by default installed in your EagleCAD software. Okay, Anindya wants me to show the tool icon. I'll be using the add tool multiple times. You can see it later. Okay, I was talking, you won't have the SparkFun boards as a default library. So now I will talk for a brief while about how to import libraries in your EagleCAD PCB. So if you have checked our Discord channel or the meeting links, you must have, or even the mail which we sent, we have links to the libraries. I'd like my friends to put the links in the chat box now. And meanwhile, I'll show you the links. If you open the first link, it's the SparkFun library. It's a GitHub link. So these are basically open source libraries in which people have uploaded .lbr files, which we will be using to. Okay, now Deepak has put up the link in the chat box. You guys can go over there. Once you're on the GitHub page, you have to go to code and you have to download a zip file. So we'll go ahead, download the zip file. So you'll see that the zip file is downloaded. Then you have to go to the file explorer in your PC and extract the zip files. So I have downloaded. So left click. I use the 7-zip extracting software. You can use your favorite extracting software. We will extract, and now we see that we have the SparkFun Eagle libraries extracted. Now you have to drag and drop this into the Eagle ka control panel. So I'll check out the control panel. This beautiful window here is called control panel. You can see that written on the top. And this is also where our project file resides. But if you move to the top of the directory, you will see that there's a section called as libraries. So you open that, and in the libraries section, you drag and drop these files. Okay, so I drag the extracted files from my file explorer and drop them into the libraries section. So right now I already have installed the libraries. So it will show me an error that you have to overwrite it. So if you install it on a first time, it won't show this error. I won't rewrite it. Having said that, we'll go back to our schematic. Okay, so now we had the doubt, where is the tool icon? It's on the right hand toolbar. It's called add part. So again, we'll click on add part, and we have searched nano. And if you see to the left side of my screen, you see a red color ka dabba type thing with pins sticking out. That is a schematic diagram of an Arduino Nano. And to its right, there are green dots wala yellow diagram. That is exactly how the PCB will look when we print it on the copper board. So without further ado, I'll go back to the left side and double click on the blue highlighted nano footprint link. And that should give me a very beautiful looking component in my schematic board. So I'll press left click and we have a board there. I'll hit escape to exit the tool, add tool wala component. And if I scroll up to zoom in, you can see there are pins written on it. Now, interestingly, I actually do have an Arduino Nano laying around. So I will stop sharing my screen for a little bit. I will highlight my own self. And if you are able to look at my faces, so this small beautiful thing is called an Arduino Nano. Do you guys know what an Arduino is? Do answer me in the chat box. Till then, I'll describe this thing. So it has a blue color ka printed circuit board. There are components from the back side also. There are copper traces which you might not be able to see. But this essentially is a microcontroller. It is kind of the brains of the circuit which we are building, and it has the holes for the pins, and it has a micro USB port through which you power the Arduino and also take data from it. Okay, and Arduino is not a flash drive, man. Okay, it's a microcontroller. We actually have conducted a workshop on this, and even if you do projects in the electronics club, This is the main component which you will use. There will be hardly any projects which won't use an Arduino. Having said that, I'll reshare my screen. Okay, so as I said, this is a schematic for the Arduino, and you can press the scroll button and pan the whole schematic. You can scroll down to zoom out, scroll up to zoom in. Okay, so what my circuit was doing, it had a PIR sensor whose input the Arduino will take, and if it detects an intruder, it will sound a buzzer. So now we will take in the PIR sensor. Luckily, the PIR sensor was also in the same library from which we got the Nano. So I'll just write PIR, we'll search, and you can see this one, the Panasonic EKMC X6 blah blah blah. These are what electronic components are named like people don't name them say Rohit Sagwekar, but they name them in cryptic codes, but that's okay. And if you look at the schematic, these are the holes which it will make on the PCB. So I will choose this, I will double click, and we have it inside our schematic. Left once, escape. Now we have the PIR sensor inside the circuit. The final component which we need for today's board is called a buzzer. I hope I don't need to explain to you what a buzzer is. It buzzes. Okay, okay, that was a little hilarious. We'll go search for buzzer. Now these buzzers are not actually included in the SparkFun library. You will have to download another library, the link of which has already been shared on the Teams chat. You can go there and check it out. Okay, so there are many buzzers, but I will choose one from them based on the schematic which is outputted on the right hand side. So I do have these kind of buzzers in the electronics club, so I will choose this one. Okay, so we have a component. Another shortcut kind of a thing in EagleCAD is you can use the right mouse click button to rotate this component. I want the orientation to be like this, and I'll place it here. And that's it. These are all the components which you need for today's circuit. Okay, so that was about choosing the right components. From now you have to wire them. So for wiring, we will use a very nice tool called Net. It's on the left hand side again. I'll click Net, and so we have VCC, which we will put in again to 3.3 volts. Again, if you are not understanding why I am wiring a specific circuit to a specific pin, don't fret. This will all be taught in subsequent workshops, but make sure to attend all of our workshops. And we have ground. Oh, we connected the output pin to ground. We did not want to do that, but it allows me to demonstrate a more important function called delete. I can just go and delete this wire. It's on the right hand side. Again, go to Net. Output is something which I want in my analog input pin. So say A6. So the output of one module becomes the input for another. Rahi baat ground pin ki, we will go and connect ground to ground. Brilliant. So that was the wiring for the PIR sensor. Then we have the negative, which will also go to ground. So let's go from below and the ground. Cool. And we have the plus, which will go to some digital output pins. Okay, people are worried about how would we know the wiring. Again, this is an advanced kind of a thing. For this, you will need to attend another workshop. So do stay tuned with the Electronics Club, IIT Guwahati. But having done that, these are all the wires you need for a circuit to work. Okay, what will happen that this lamp will detect an intruder. It will give an output current to the Arduino. Arduino will run the code where it will know if I am getting an output current, I should give some current to the buzzer so it buzzes. and in the digital output pin, it will send a pulse which will activate the buzzer. And that was all. Okay. This was the first phase of PCB design, which we called as schematic building. Now, if we do have any doubts until this part or people are lagging behind, please let me know on the Teams chat. I will take a small break of 2 minutes for here and wait for you guys to catch up. Yes, second part जल्द ही आएगा. So while we are waiting, can you guys tell me some other kind of sensors which we can interpolate with the Arduino? Can we design a board, not import? Yeah, Naman, I don't really understand your question. Yeah, like we are going to design a board after this. The next phase of the PCB design process is making that green color ka plate kind of a thing. We will soon move on to that. Ah, yes, infrared sensor. Yes, yes. Tushar, Rajan. Nice. Temperature sensor. That's also very nice. Light sensor, if we interrupt it, it buzzes. Ah, you see, infrared sensor is technically also a light sensor. But like I do understand you wanted to mean a photoresistor kind of thing. But that's okay. We can make a intruder alarm. Oh, raindrop sensor. This is actually very nice. We actually are using a similar circuit, a rain sensing circuit in another project, which the electronics club is doing. So do attend the workshops so you may also be able to join other projects. Okay, so enough talking of mine. Yeah, Naman says I imported Arduino. Yeah, basically I need to have that component to be able to find a pin out. Bole to the green color ka schematic, which I showed you, that is what will be available on the printed circuit board. Okay, I will go on about importing later. But right now we'll go to the more beautiful, more artistic part of the workshop. So you see this pretty button here. It's called generate/switch to board. On the top toolbar, it looks like a square with a green and white part. I will click on it. It says I don't have, oh, I should save this thing first. We will name this, say, PIR intruder detector. Oh, nice. And I'll click on generate board. Right. Beautiful. So now the thing which you see here are the layouts of the components on a PCB. So a PCB is essentially a board with only holes in it, holes and copper traces. The components you will place inside these holes and solder them accordingly. So now I'll begin the fun process of moving these components into my board. We will use the move tool from the left side of my screen. I'll click on the center part. Now, as you see, when I move these, there are some yellow lines which are connecting the components to my nano. These yellow lines are what they call as air wires. Air wires bole to, they are moving through the air and they kind of describe where the actual traces are going to go. Having said that, now there are some things which we should make sure while placing components on a printed circuit board. Number one is that the air wires should intersect minimum times. So like if I place it here, you can see that these air wires are crisscrossing on a lot of occasions. This will create complications when we generate traces. There are some other things which you need to make sure while you're placing components. I'll ask a kind of a difficult question. So for example, if you have two inductors in your circuit, is there any special precaution which you need to take while placing two inductors in a circuit? Again, the chat box is yours. Please type in your answers. I'll repeat my question. You have designed a circuit which uses two inductors, and you have to place these inductors in such a certain combination. हाँ ओके क्लोज रखना होगा बट थोड़ा रीजन वगैरह भी दे दो ना मेरे को, मतलब ऐसे ही थोड़ी. Why is the reason that we have some very smart freshers right here. So we have Aditya and Khushi who are talking about mutual inductance, which is very nice. So if you have two inductors, they have a magnetic field running through them, which extends or it's extended outwards of the body of the inductor. So you can't keep them in a straight line, else the magnetic field of one inductor will affect the other inductor. So there are other things also which you need to take care. Even these lines, when you create a circular line, there is going to be parasitic capacitance of the traces themselves. Then you have to make sure that if you are including ports, if you have a say an 3mm audio jack or a power port, you need to keep the ports facing outwards from the PCB. But yeah, these are the things which you need to make sure. I'll also use the wire tool to draw line tool to make sure that this PCB is not wasted. Okay, we will select a dimension layer on this. What these layers mean are, because if you remember the presentation, a PCB is made of many layers. So the red layer represents the very top layer of copper. The blues represent the bottom layer of copper. The greens represent the holes which are going to be in our circuit. And that is the kind of thing which you need to be aware about. So I'll draw a rectangle near this. So yeah, that is the final PCB which we have for our PIR sensor based Arduino Nano intruder alarm. Great. So this looks very beautiful, I know, but how will it look in real life? For that, you can click on manufacturing tab and it will give you a preview of how your board will look. So you can see that there are golden pins and there are insets where we will insert the components. But even now, the yellow color wires are still air wires. We need to convert them into copper traces. So this is done using a process called as routing. So we have the route tool, route air wire tool, which you can use for manually placing the currents. But EagleCAD also offers us a very strong functionality called the auto router. So you go to Tools tab from the top, you click on auto router and you select continue. Okay, now I want you guys to observe the circuit very closely because this thing frankly looks magical. So I'll start the auto routing process and we are done. So it automatically generated these red color paths on the PCB, and these represent the copper lines which will be printed on the PCB through which our current will pass. So we'll just end the job. And if we go to manufacturing tab now, you can see that the traces are visible right there. Okay, you have traces. These are what they will look. So this looks very pretty right now, but there is a small way in which it can look even prettier. So I'll save this, Control S. And if we have people who attended the Fusion 360 workshop, which we conducted recently, Fusion, the company Autodesk, which generates Fusion, also creates EagleCAD. So we can actually access files from Eagle into this. So we'll wait a few till this Fusion launches. Till then, I would also like to tell you what we will do in the next part. Basically, I am done making this PCB. If you had seen the Teams group, before the meeting, we have shared a very pretty circuit, which is the 555 timer based square wave generator. And in the next part of the workshop, we will pick a lucky person from you guys who will share his screen and create his very own 555 timer based square wave generator PCB. And of course, we will be here to help him. So now my Fusion is open. We will go to open files from my computer. I will navigate to where these are PCB workshop, intro the detector, and I want the board. So I open the file, wait for it to generate in my 3D environment. Okay, so this is the board which we created, very pretty. And if I press this push to 3D PCB, one more thing, you guys aren't required to follow me in this part. You can just create your PCB and stop there. I am just doing this for demonstration purposes. And it will generate. And there we are. This, my dear friends, is how our PCB will look in the final edition. So I can view this 3D file in different dimensions. I can zoom it in. You can see that there are holes on the other side. We will pass the leads of our components through these holes. And this is how the PCB will look like. Now you guys will ask me कि भैया कि ये तो मतलब सॉफ्टवेयर है, इसको आप actual 3D real life model कैसे बनाओगे? So there are machines called as PCB millers. We actually do have a PCB miller in the campus. Once you guys are back in the campus, we will be sure to demonstrate it for you. But the files which you put as input in the PCB miller are called Gerber files. There is one file for each layer. So how to generate that? You go to file and there's something called as CAM processor. You click CAM processor and you select a board which is PR into the detector and you click on process job. I'll select the same folder and if I go back to the folder, CAM outputs, Gerber files. Yes, these are the files which you give as input to the PCB miller. Basically, it looks like a 3D printed with a drill on it, and you input these files. You put a blank PCB, and it mills the PCB, and it creates the copper paths. So having said that, I will cut this off. Okay, and with that, we are at the end of the first circuit for today. Now, I would like one of you guys to volunteer up for the next part. Basically, you guys will have to share your screen and I will give you instructions and you have to create a PCB for yourself. The requirements of these are you need to have a stable internet connection. And it would be great if you are using the Teams app instead of a browser version. So do we have any volunteers? Do text on the Teams chat so we can give you the presenter access. Oh, we have a lot of hands raised. Okay, let's see. We have Naman and Rashmi. Okay. BTech students. Okay, Rashmi. Okay, Naman, we will make him a presenter. Yes, Naman, you should be able to unmute yourself now.
Hello, I'm audible. Am I audible?
Yeah, great. You're audible, Naman. Where did Naman? Hello, Naman.
Yes. What actually I need to do? Can you explain?
Yeah. So in this part, you have volunteered for creating your very own PCB. I hope you have EagleCAD installed and running.
Yes.
Okay.
Don't have the libraries actually. I did follow that.
Yeah, we don't need the libraries for these. The next part, all the components are already pre-installed in the EagleCAD software. Having said that, I will stop sharing my screen. And Naman, you can share your own screen. Are you enjoying the workshop till now, Naman?
Is my screen visible?
Yeah, your screen is visible.
Yeah, basically, I'm enjoying in a way.
Okay, great. You're an engineering physics student, right? Yeah. Your department does need a lot of circuit design and kind of things. Anyways, okay, great. We are in the EagleCAD software. I will request control of your meeting. You might get a request. Please accept. Okay, now I should. Yeah, that mouse is mine. Okay, great. Now, Naman, did you see the circuit which we sent before the meeting, the square wave generator?
Not exactly.
Okay, we will have my friends put up the circuit in the Teams chat. Yeah, Yadla has put up the circuit. Yeah, can you see the circuit?
Yep.
Any guesses on what it does?
It generates, it transforms a wave to square wave, like the rectifier used to convert AC to DC.
Yeah, it's kind of the similar. It uses a 555 timer in an H-table mode. You guys will learn, especially the guys who are in ECE or EEE, they will learn these components later. Okay, you can move on to the EagleCAD software. Okay, you have a new project, right? We'll create a file in this project only. So file new schematic. Yeah, you can go for new there. Need a schematic. So you do remember what a schematic is, right?
Yeah.
Okay, cool. Okay, let's start by adding the very main component of the circuit, which is a 5-5 timer. Okay, go to add tools. Between two asterisks, you write 5-5 timer.
Firefighter timer.
5-5 timer. In numbers. Space timer. Okay, and you search. Okay, yeah, the very first one. Above that, yeah. Click on the, yeah, you need to expand this thing. Yeah, click on it. Okay, so on the right side of the screen, guys, they even have provided a 3D model of what the 555 timer looks like. So it's an IC, an integrated circuit. It looks like a black color kadabba with many legs, like a caterpillar. And the green color shape is what will be printed on the PCB. Having said that, Naman bhai, please double click on the blue color highlight. And that is the circuit which you have. So you click it once and it will place. Great. Escape to release. Cool. Next, we need a couple of capacitors. So you go to add part and in two asterisks, write capacitor.
Which one?
Anyone will work. Click on the first one. Yeah, this one looks decent. Double click. You have to double click on the blue color highlight.
You did.
Acha, you need to, because that was a generic collection. You have to click on a more, yeah. This is good. Double click on the, you can just click OK. Okay, now you see where the capacitors are in the circuit. Okay, so they are approximately below and to the left of the circuit. You place a couple capacitors there.
Actually, there are no pins in this circuit.
We will do the wiring accordingly. You just place the capacitors there. Okay, this is good. Escape to release. Now scroll up to zoom in on the function, or you can use this very pretty function called as zoom to fit. It's here. You see my mouse? Great. Okay. Now if you go to the circuit,
Okay.
Yeah, circuit diagram. There's a ground terminal on the bottom part of the circuit, if you can look, right? So we'll need to use the ground component, go back to EagleCAD. Yeah, add tool. Ground. Okay. What?
This one?
No, wait. The last one? This one. You do know what a ground is, right?
Yep.
It's the reference voltage. You measure all voltages from ground because voltage is a relative thing here. Anyways, so now we have placed that. We need two resistors now.
Resistors.
Okay, click on any one of them. This is not the thing. Let's see. This one is good. Open this thing. Oh, not a variable one. Click on any one of those. Yeah, this is decent enough. Okay, check out in the schematic where you need to put the resistors. Right. Now oh, you know the right click function. How nice of you. Give some space between the registers. That is a decent enough. Escape. Yeah, cancel the add tool window and we'll zoom to fit again. So this is the circuit which we need to wire up right now. Okay, this was the component collecting part. So use the net tool. It looks like a green color ka L which is sleeping. Cool. Now I will help you in this part. Let me see the schematic on my own system. Wait a second. Okay, so now you need to connect ground to terminal 1 of the 555 timer. That is connected. An advice for you, do some Control Z, do some undos. Yeah. While you're placing the wires, you can click on points on the blank space and it will create a node there for you. Okay, try it now. Brilliant. Okay, so we have 1 to ground, then we need 5 to one of the capacitor ka pins. Yeah, put it to the one on C2. Put it on C2. No. Okay, fine, wait here. Now you see, while you did that, you actually created a junction on C1, right? So you don't want that. You should be careful about that.
Okay.
You click on the tip of the wire. You can click on it. Okay. That's decent enough. Okay, so we have 5 to C2 and both the other ends of C1 C2 to ground. No, the thing is the terminal, the pin of ground ka triangle is where you connected to the first wire. You see that small dash? That is where you need to. You can just connect it to the green wire and it will be galvanically connected. That is enough. Yes, say yes. Okay, that should be enough, right? So now they are grounded. Now we need to connect C1 ka upper terminal to pin 6.
Pin 6.
Brilliant. Now we need to make a junction with 2 to that line you just created. Cool, perfect. Okay, then we need to bring this junction to the bottom end of R2. That is recent. Then 7 to the top end of R2. Okay. Now a wire from the top end of R2 to the bottom end of R1. Okay. And then the top of R1 connect to 8.
8. Okay.
And 4 you connect to the wire you just laid. Anywhere on the wire. It did not create a junction. You clicked on Control Z. Yeah. Brilliant. Now it is galvanically connected. Let me just verify if the circuit is correct. 3 is free, 1 is there, 5 is there. R2 and R1. What are you saying?
Nothing.
Okay. Okay, and the third pin will be an output pin. We'll get the square wave between ground and the third pin, right? Okay, I think this is correct enough. So now let's create a schematic. Do you know how to create a board from a schematic?
First, we need to save the project.
Good. Just call it anything you like. Okay, after this.
Then actually after this, what we need to do? I forgot after that.
Okay, it's perfectly fine, Naman. So you have to click on this pretty icon here. It's called schematic to board. Create from schematic. And yes, you can scroll up on this. And this is where your schematic will be there. Yeah, you can even do zoom to fit again.
No.
But it will fit the whole screen. So it does not work. Anyways, you zoom in too much. Yeah, this is good. Now use the move tool. The one here. Yeah. And place the components.
It's not leaving it.
What do you mean? You have to place it on the board, right? On the dark black.
Okay, sorry.
That's okay, Naman. Yeah, you have to click on the very center of the component where the plus sign is there. You deselected the move tool. You're not on the move tool right now.
Okay. How can I get it back actually?
Yeah, you click on this thing right here. Wait, I will help. So, do Control Z. Your drawn wires. Okay, cool. So I can. No, not on the move tool. Okay, so I have the move tool. I have this selected. I can move the whole thing there. Can pan it. Place it here. And likewise, you do with the other components.
Okay.
Yeah, you can use. Does your mouse have a scroller button?
No, not actually. I'm using the touchpad.
Oh my god. Okay, you should use an external mouse for it. Okay, I'll help you a lot then. Yeah, for 3D modeling and PCB design, a touchpad is kind of difficult to use. Oh, I did not place it. Okay, and we'll try to make sure that there are minimum crisscrosses. So I am individually selecting these components and moving them so that the crisscrosses are minimized. Don't worry if you're not able to avoid 100% of crisscrosses, that is okay. This is good. This one. So I'll keep here and R1 I'll shift.
They are connected actually.
Huh? How are they connected? We should not be connected. Oh, they connected it using a single this thing. Okay, that's fine, I guess. Okay, having done this, we will now use the auto router tool. Do you remember what that is?
Auto router.
Yeah, continue. Start. End job. Press Ctrl S to save this thing.
Done.
Brilliant, brilliant. Now if you go to the manufacturer tab, you will be able to see your own schematic. Magic, yes, Anindya. It's really magical. So it does not allow pan, I guess, but you can scroll to the bottom part. There you can see that there are traces, and then there are the golden pads which are exposed copper, and you insert the pins of your components and you solder them from the opposite side. Having said that, congratulations, Naman. You have successfully created your very own printed circuit board. You can send this to us, and if you ever come to the campus, you can actually make this board into a reality using the 3D Miner. Thanks a lot, Naman. You have been a very good PCB designer, and I'll allow you to turn off your screen sharing. And with that, we have come to an end of the demonstration wala part. I will invite my dear friend Shankar Madira, who will tell you about the assignment which we have planned for you guys. Thanks a lot.
Yeah, hello people. So I hope you have learned something and most importantly had fun in this workshop. So now coming to the final part. So here is an assignment for you guys. Okay. So you have to make a schematic and a PCB design of the circuit in front of you. You can see that, right? So it is pretty simple because Rohit has done a great job explaining how to do it. So this must not take so much time to do for you to do. So you have like 4 days, 17th, and we will give the detailed instructions of how to do it. Like not exactly how to do it, the submission and all of it in the teams. Yeah, that's it for now. So do you have any questions? Yeah, just wow. Yeah. Anything do you want to say about the workshop or something like that?
Just a second, Shankar.
Yeah.
Actually, I just want to interrupt for some time. Those who are submitting the assignments, we will be giving the certificates for this workshop because this is a new domain in the campus. So just please submit the assignment within the timeline, that is 4 days. So just submit the assignment. We will provide you the certification for the respective thing. Thank you.
No, it is an individual assignment. Like everyone has to do their own thing. It is pretty easy. So yeah, I just share. Like we just share it in the Teams, the folder, and the Google Forms link. Yeah, and everything. Yeah. So that's it, I guess. Anything else, Mansi?
Yes, we can conclude the workshop.
Yeah. So people, thank you for attending the workshop. There are so many other workshops you're planning. So please do attend them to know more about electronics and stuff. Yeah. Thank you.